I'm turning on my screen recorder and sharing with you guys my notes. This is section 4.10, okay? So this is our last section in chapter 4, and it's going to sort of jump off. It's going to be a jumping off point into the next chapter, which will be the last thing we talk about this year. And the notion is all about antiderivatives, okay? So just from the name, what do you guys think antiderivative might mean?
The reverse of the derivative.
Absolutely. That's, you nailed it, Ethan. Very good. When we talk about antiderivatives, I hate to use the phrase inverse operation, but it's sort of, how addition and subtraction undo each other, and multiplication, division, squaring, square rooting, and there are little caveats along the way, of course. But the notion of taking the antiderivative, okay, the idea of antidifferentiation is sort of like Ethan just said, the reverse operation of taking the derivative. Now, there's going to be, just like with derivatives, and we've been studying this last few months, applications, there are a boatload of applications to the antiderivative as well. So let's talk about notation first thing. And I've got on my screen, obviously, some things that you guys should be writing down while I'm talking here. But look at the notation that we use, okay? As far as the function goes, we use a capital letter, okay, to denote the antiderivative. All right. So whereas we use f prime is the derivative, capital F is the antiderivative. And again, we're still at the point right now where we're just kind of like, well, I don't know what that quite means, and that's okay. We're working with it. But notation-wise, we use a capital F or capital G or capital H, whatever the function's named. We use a capital letter to denote that, hey, we're talking about its antiderivative. Okay. Now, one other thing that I note here is I use the indefinite article, right? What do I mean by indefinite article? Some of you grammarians in the house. Okay, Connor Manis, I know you're an athlete. You like sports. Connor, if I asked you who is the greatest basketball player of all time, who would you say?
I would say Michael Jordan, but a lot of people don't agree with that.
Sure, and that's the question. The episodes 3 and 4 came out last night. I haven't watched them yet, but he's actually got a 10-part documentary right now called The Last Dance about his 97-98 season with the Bulls. When you use the words the greatest, you're saying the one, the only, the GOAT, and that's, you're not leaving room for anybody else. Okay, what if I said, Connor, can you name a great basketball player? Right? You could probably come up with a ginormous list, right? You know what I'm talking about? Like, so you got LeBron, you got MJ, you got Kareem, you got all these different basketball players that you could name. The idea is that we're using an indefinite article when we say it like that. Tell me a great basketball player means there's more than one. Tell me the greatest, and we're saying there's one and only one. So when you use the indefinite article here, an antiderivative, because it's not the only one, okay? I'll show you what I mean. Just a little side note right here, okay? X squared. What's the derivative of x squared?
2x.
2x. That's easy. That's cake, right? The derivative of x squared is 2x. Okay. Now, if I went in reverse, right? If I said, what's the antiderivative of 2x? You're going to learn through today and tomorrow and on into the week, you're going to learn the process by which you would say, oh, yeah, the antiderivative of 2x is x squared. Okay, so when you're differentiating, you're going from one to the other. When you're anti-differentiating, you're reversing it. You're going backwards. But you know what? 2x is not the only antiderivative of x squared, right? What if I gave you the function 2x plus 5, right? If you think in reverse, you think, what function has 2x plus 5 as its derivative? You would also say x squared, okay? So the idea is like, hey, if I asked you guys what's the derivative of x squared, you again would just say 2x. But if I said what's the derivative of 2x, or excuse me, what's the antiderivative of 2x plus 5? You would say, x squared. So in other words, back to our main screen here, the idea of the antiderivative is it means that there's not only one, there's many. There's infinitely many, as a matter of fact. So key in down here with me on this red text right here where we say f of x, the antiderivative, plus c, where c is some constant. That's how we're going to express all the possible antiderivatives. And this c is going to be very, very, very important. I'm going to go ahead and plant the seed right now in your minds. Don't forget c. Okay? Don't forget c. Later on, we'll name it. We'll call it our constant of integration, but that's putting the cart before the horse. All right. So let's look at another example. I know I've given you kind of a sidebar already in this vein, but consider 3x squared for me, okay? And I asked the question, can you think of a function whose derivative would be 3x squared? Okay, so I'll throw this over to, I don't know, Hayden Johnson. What do you think? Can you in your brain think of a function who would have 3x squared as its derivative? What do you think, Hayden? Any guesses?
Would it be like x to the third?
Absolutely right, man. That's awesome. So, like, that's a perfectly good example. Very well done, Hayden. That would be an example of a function, okay, that when you differentiate it, you get 3x squared, okay? So, like, if I said, hey, guys, take the derivative of x cubed, what Hayden gave us, then every single one of you guys should be able to say, oh, yeah, it's 3x squared from our power rule, right? Okay, but that's not the only answer, okay? Aaron, could you think of another answer, besides x cubed that would have 3x squared as its derivative? And kind of remember what we were saying over here on our sidebar about what we could tack on at the end right there. What else might have 3x squared as its derivative?
Like, I'm trying to think. Hold on.
Giving you a hint right here, highlighting it in yellow.
Where c is a constant.
Pick me a constant and throw it on the end of that, and you got it.
So, like, just any constant? 4.
Okay, so very good. Voringer's answer right here, class of x cubed plus 4, does it muster up? Is the derivative of that 3x squared?
Yeah.
Of course it is. Okay. So like you can tell, okay, so just right out the gate, we had Hayden gave us x cubed. Aaron gave us x cubed plus 4. What if I got x cubed minus 1 or x cubed plus 7 or x cubed minus pi or whatever? All of these functions, write down in your notes, all of these functions are antiderivatives of 3x squared. Okay? These are all antiderivatives of 3x squared.
What about 0?
That would be actually like what Hayden gave me as an example. You know what I'm saying? So like he didn't write a constant in there. So that would be just the same as plus 0. Right? So how can we generalize this? Well, what we could do is we could say, generally speaking here, given that f of x is 3x squared, the antiderivative, capital F of x, would be x cubed plus c, where c is a what? C is some constant. Okay? So what you're doing is you're teaching your brain to think in reverse. All right? Now, how many of you guys have seen, I love YouTube. I'm on YouTube all the time. One of my favorite channels is called Smarter Every Day. There's a guy named Destin. Anybody ever seen Smarter Every Day?
I've seen it.
I've seen it once.
If you haven't seen it, dude, check it out. He's an engineer and he's an educator and he like makes neat videos about just like cool stuff. Okay, and answers like questions about why and one time I think he was one of the ones that like he built a trampoline and they dropped a truck off of the trampoline and it bounced and landed. No. Actually, that's I'm sorry. That's another dude. I'm getting my YouTube engineer guys confused. But anyway, one of the things that this guy actually did, Destin, Smarter Every Day, he built a backwards bicycle. Okay. Now think in your brain how a bicycle works. Okay. Watch my hands right here. A bicycle works in that if I turn the handlebar this way, my bike's gonna go this way. If I turn a handlebar this way, my bike's gonna go this way. He built it. He engineered it to where if you turn the handlebar this way, the bike will actually go left. Anybody seen that particular video on YouTube?
I saw it.
Yeah, I've seen that.
He goes around, he tours the country, and he bets $100. He says, I'll give you $100. Like he's up on stage. Like let's say he came to Christian Brothers High School and he was up on stage. And he said, I'll give $100 to anybody in here that can ride this bicycle. And they come up on stage and they try and they fall over and they look stupid. And that's because your brain has been trained to think, turn the bar this way and I go this way. And it's so interesting because he sat in the video is really funny because he teaches himself how to ride it. Okay, to where you kind of balance out in a reverse direction. And you know what the really crazy thing is? Once he learned to ride it that way,
you had a hard time unlearning it.
yeah, you give him a regular bike, Newhoff, and he can't ride it anymore. It's the craziest thing. So like what he did was he trained his brain to think in that reverse direction, and that's all his brain could think. For like the next week or so, until he eventually quit riding the reverse bike and started riding a normal bike again. Check the video out. It's really neat. It's really interesting. But the reason I mention that is because our brain has been taught over the last 9 months to think in one direction regarding differentials, regarding derivatives. Okay, so your brain has been taught to take that 2, to pull it down front and subtract it by 1. But that's not what we're doing. We're going to work in the reverse direction. Okay. All right. So that being said, let's wrap up class today by looking at these 3 examples and see if we can train our brain to think in the reverse direction. Okay. All right. So first things first, you look at part A and it's 1 over x. Now, if you guys in the back of your brain, if you have memorized, there was some derivative rule that we had learned that the derivative of something equaled 1 over x. Who could tell me what that function was? Whose derivative is 1 over x?
The natural log.
Very good. Very good. It's natural log. So what we would therefore say is we would say, oh, okay, the antiderivative, capital F of x is the natural log of x, and then what can't I forget to put on at the end?
Plus C.
Plus C. Remember how we said don't forget that constant. And the way that you check your work, and this is what's great, the way to check your answer is to simply take the derivative of it. Write that note down for me, please. Okay, the way that you guys check your answers on these is just simply by taking the derivative. All right, so we kind of did that one corporately. Let me throw this one over to Ian. Ian, what do you think? Can you imagine a function, Ian, whose derivative is cosine? Hans, you with me today? All right, Davis, what about you? Davis Hopper?
Coach.
Can you think of a function whose derivative is cosine?
What's that?
Can you think of a function whose derivative is cosine?
Oh, sine.
Very good. Okay, and what should I put at the end of it?
X.
Davis, are you paying any attention, Bubba?
Yes, sir.
Okay, good. What did we put at the end of our previous example? Bro, just look at my screen. It's in blue.
Plus C.
There you go. Good. And in the previous example, in orange, plus C. And up here in red with highlights, plus C. So class, we don't want to forget our constant to put at the end. So very good, Davis. Plus C is in fact what we want. All right, so if you look at part C now, like I said, these are some of the basic rules that hopefully we have memorized, okay? So, Amish, can you think of a function that has e to the x as its derivative? It's one of those that we had memorized. What do you think, Patel?
Was that was e to the x log?
Not log.
Coach, is it just e to the x?
You are correct. Jack, is that you?
Yeah.
All right, excellent. Yeah, you're right. It is just e to the x. And then, Amish, what do I want to put at the end of it?
Plus c.
Plus c. Awesome. You guys are tag teaming that one. Very good. So in each of these examples, look at a couple of the things that we note. Okay, so first of all, the way to check your answer is to simply take the derivative of it. Don't forget to add c. Okay. All caps rage. Don't forget to add c. And then another thing is it's helpful to consider basic derivative rules. Like, we're not doing anything uber complicated here. We weren't like decomposing or reverse engineering the product rule or the quotient rule or the chain rule or anything. These were all three basic derivative rules that we had memorized. So like if I rolled up on you guys tomorrow, not that I'm going to, but if I rolled up on you tomorrow and said, hey, what's the derivative of natural log? What's the derivative of sine? What's the derivative of e to the x? Those are all three functions that we've memorized their derivatives of, right? So just remembering those rules can help us work in reverse. Okay. Hey, really good class today. Do y'all have any questions for me before we go, fellas?
No, sir.
Coach Morgan.
Yes, sir.
I didn't turn my sign because again my internet was just messing up because all my brothers are on it. Can I turn it in today?
Yeah, and actually, you know, I meant to mention this earlier in class. I had several people that over the weekend they completed some missing work. Whenever you guys complete missing work, just shoot me an email, say, hey, FYI, I made up so-and-so, or if it's one that you're taking a picture of, obviously you got to email me anyway. But just remind me or let me know, and then I'll get to it as I can throughout the week, update and grade book stuff. But yeah, Bart, that's fine by me.
Did you get my email, Coach? I sent you.
Yeah, I got one from Bowringer. I got several from McDonald.
Okay.
I got Hostway emailed me. I've got several of you guys had emailed me, and it'll just take me a little bit of time to play catch up on that.
Yeah, hey, Coach. When I was doing the Albert, I accidentally did one that I was supposed to do a while ago. So I'll show you an email, but I did really bad on it because it was like 2 weeks ago.
Yeah, just hey, especially with like things like Albert and Delta Math, those programs are not set up to notify me once a student completes it. So yeah, Connor, that's fine if you completed it, even if it was a bad grade, it'd be better than a nothing. Shoot me a line and let me know, and I'll swap that out.
Thank you.
All right, fellas, y'all have a great day. Live Jesus in our hearts.
Forever.
All right. Thank you, fellas.
See you, Coach.